This is Jim. We're going to do state machines. First, we're going to put it into a Blank.vi, and then we're going to show how to utilize that once it's been debugged, the same scheme in the robot program. So we're going to have a two-part episode. The first part is on a toggle function. So we want to use the same joystick button and be able to turn a system on and off repeatedly. And so that's one of our simple state machines. The second one, we're going to use two buttons, a set and a reset, and we're going to turn on and off. And again, there's value in being able to simulate this in a Blank.vi. The state machine elements include a while loop that's going to have a constant loop control variable fixed, a time delay. It's going to have a case structure that will enumerate each of the cases, and an enum function or variable that allows us to use multiple cases rather than just the two that are in the case structure. And then the next state trigger, which will determine the next state we go to. So again, the advantage is being able to ring all this out in LabVIEW before we have a robot built. So let's jump into LabVIEW. So I've opened a Blank.vi and I've put on it a button. If I right click, go to the Boolean menu. In this case, I'm picking up a rocker and putting it here. And then we're going to be controlling a motor. So I'm using a meter to represent the motor control signal. I've set it up to run from -1 to +1. With the motor, we're going to run it at a constant speed in one direction. So we'll see it when we get there. So I bring those variables down to the bottom and we'll put them into the state machine as we need them. The first element in a state machine is a while loop. You can recognize the while loop because of the orange dot in the bottom right-hand corner. We're going to right-click on the loop control and create a constant. The false will never let this change value, so this loop will continue to run. We always want to put a delay time, so we're going to wait. Because this is human interaction or human controls, we're going to make it relatively slow. So we're going to create a constant here, run this every 150 milliseconds, which again is pretty slow. All right, the states, the actual states are parts of a case structure. So we're going to input a case structure. Again, I'm on the structure palette. It's the one with the question mark in the left-hand side wall. Take up most of the space in our while loop. And now and you'll notice we just have two values, a true and a false case. We change this to a state machine by using an enum. Enum, if we right-click in an open area, go to the numeric palette, we find enum down here next to the bottom row. We put it right there. We're going to right-click on it and edit values, edit items. And so insert, I always like to start with the init. So I'm going to go back to my first item. And the first state's going to be init for initiate. The second state's going to be off because we want to immediately go to the off state. And then the third state is on. We're going to click that as OK. Now we're going to connect this to this control signal in the case structure. We still just have two states here, two cases. I'm going to right-click in the control box for the case structure and add a case for every value. And as we do that, now we'll notice we have three cases for each one of the variables that we set up in the enum. Now the next thing we need to do is incorporate a memory element. If we right-click on the tunnel loop or loop tunnel and replace it with a shift register, the shift register serves a very useful purpose of carrying the results that have been generated inside the loop out through this shift register back, and the next time we run the loop, it's going to use that value as the input here. So we're going to start with init. During init, we want the meter, or rather the motor, let's put it up here, to be a 0 value. So I'm going to create a constant, bring that 0 inside my case structure. Now we want to immediately go to the next state. So we're going to create a constant here on the shift register because it knows what we're looking for. It's looking for a copy of the enum, and the second time through this loop, instead of going to init, we want to go to off. So we have this state complete. When we go to off, again, we want the motor to be at 0, so we're going to right-click, create a constant for the motor. And now I'm going to use the select switch to be able to make a decision to change states. Select switch is in the comparison palette, third row, left-hand side. Looks like this. So when it's in a negative state, or when the signal coming into the center is false, we want to maintain the state that we're in. The state that we're in is controlled by the output, or whatever value is in the shift register. And as that comes through, it will keep us in the current state of off. Now, the thing that's going to change that is the condition of this OK button. If I right-click on it and create a local variable. Now, this is similar to what I use in a robot. We're going to bring it up here, right-click and change to read, and then pipe that into the center of our control of the switch. The center connection is the Boolean. Now, as long as the OK button, or this button, is negative, nothing will change. We'll stay in the off state. As soon as it goes positive, then we're going to go to the on state. So we're going to create a constant. Again, it's going to create a copy of the enum, and we select on, which will take us to the next state. Now, one of the things that I like to do, a drawback in this is that if you hold down the button too long, you can cycle all the way through multiple rounds of this. So I like to put a little bit of a delay inside the loop. And so if we've got 150 milliseconds as far as the total delay, I'm going to put about 50 milliseconds here just to kind of give it time so we can let go of the button. All right, so we're going to go to the on state. Now again, our motor now will be at the control or the run value, which will be 0.5. And we're going to set up the same select switch routine. Go to the comparison palette, pick up the select switch, pipe it into the shift register. As long as that button is in the negative position or false, we want it to stay in the state that got us here, and that's the on state. But as soon as we click this button, it's going to, again, I'm going to create a local variable the same way I did before. And when this button goes true, then it will select this other value, and that will be sent to the shift register. This other value will be pulled from the enum, and we're going to pick out the off state. So let's see if it works. Run it. Click it once, it goes on. Click it a second time, it goes off. Click it once, it goes on. Click it second time, it goes off. Now, for those of you that are going to try to repeat this, and I encourage you to do so, one of the things that I did, if I right-click on the button, I can look at the mechanical properties, and I have this switch until release selected, so it works better than any of the other states or mechanical actions that you can see for the button. All right, that's That's what it looks like in Blank.vi. Let's go put it into a robot. And I would put all of my state machines in the periodic tasks. So here's a robot project that we've set up to evaluate a Limelight offboard camera. And the function that we need to incorporate is a toggle switch for the camera mode. So if we look at the block diagram, we can see here we're writing the Limelight, I want the camera mode, the Limelight camera mode as we change the value inside of our state machine. We're going to initiate the state machine as default, and the value is 0. And then we want to go to the vision state. When we go to the vision state, the value is still 0 on the right, the control for the Limelight camera. But now we're going to stay in this vision state until button 2 gets depressed. When button 2 is depressed, then it's going to go to the driver state. And it'll stay in the driver state until button 2 is pressed again. Now the thing that I didn't do here, and I'm going to do it right now, is I'm going to make this external loop 150 milliseconds, and I'm going to put a little bit of a delay inside. Now joystick buttons aren't quite as sensitive as these front panel controls are in LabVIEW, but if somebody has a heavy or a slow finger on a joystick, this will help keeping us from just cycling through all the different values. All right, so now I can push the button, turn on the system, and it will initiate. And instantly go to the vision mode for the camera. And then once I press button 2, each time I press button 2, it's going to toggle between vision and driver. All right, that's so much for this. I encourage you to watch the next episode, which is going to be a set reset function. And then I'll have a third, actually, I'll just talk about it now. This is the same type of situation. This is another state machine to change the LED illumination. We initiated the state machine. We have an off state. We have an on state. And we have a blink state. So it worked exactly the same, except now it's a 3-stage. We have 3 values in a init, and we fill in each one. And I'll walk through that in a third webinar. Good luck.